All right, welcome back everyone. We are on video number 4 of Math 565M, week 15. We just worked on some measurement division, and now we're going to move on to partitive division and think about how partitive division might be used to develop fraction concepts. So the book Extending Children's Mathematics, Fraction and Decimals by Susan Empson and Linda Levi is a wonderful resource that engages the philosophy of cognitively guided instruction, but also gives us examples of the different types of grouping problems that we might use, kinder to grade 6, for development of measurement division, multiplication, partitive division, and ideas around fractions and decimals. So it's a really wonderful resource, and hopefully your future school sites have it. So remember, when we're developing partitive division or fair sharing, equal sharing problems, we want to have more items than shares to make the problems easier. For example, if 5 kids are sharing 25 blocks, that's going to be easier for young people to engage in initially. Then they'll be able to pass out the wholes first. And for example, if we have 4 kids sharing 5 brownies, then they only need to sort of have that productive struggle with what do they do with that last brownie. If you are doing equal sharing problems, you might have smaller numbers, 1 or 2 of items left over after passing out wholes. Those might be easier for those younger grade students who want to engage in this type of work, and often only need to create unit fractions. So especially with beginning fraction concepts in equal sharing problems, you might want to make sure that the remainders are unit fractions, which means 1/4, 1/3, 1/5. And remember that the standards guide us and help us understand what kinds of fraction concepts people in first grade and second grade need to be dealing with. And usually in second grade, they need to understand 1/2, 1/3, 1/4, and 1/6. For example, you might have 4 share 6 brownies. Another thing to consider when you're developing equal sharing problems is problems where only halving or repeated halving is needed can be easier. Half is the most familiar fraction, and in fact, young people will try to half even when it doesn't make sense with the number of shares, because that is what they're most familiar with. So for example, if you had 2 or 4 shares, or the number of leftovers is half of the number of shares. And then large number of shares can be harder for young people, so we sort of reserve that for more experienced mathematicians or having already engaged in a number of equal sharing problems. So this may require more than one type of partition, and it can facilitate discussions of equivalent fractions, and we'll look at an example of this shortly. So now we look at fair or equal sharing with partitive division. So now we're equipped with sort of ideas around how we might write these problems for young people. And let's take a look at this special type of division, of partitive division, called equal or fair sharing, where the amount in each group includes or is a fraction, not only a whole number. So we might have 5 kids, and we have 4 brownies, and we have to distribute that amongst those kids and figure out how much each child will get. And in this case, we often work with food quantities or other types of quantities that can be divided rather than actual turtles, for example, because we couldn't cut a turtle in half. So we want to be careful about the context that we design here as well. And is always a fraction involved in the number of parts in each group. So children can build understandings of fractions from what they know about whole numbers by solving and discussing equal or fair sharing problems, and partitive division problems can be where the leftovers can be partitioned. So if we think about kids thinking about fractions, that kids can solve equal sharing problems and create representations of fractional amounts before being introduced to formal fraction terms and symbols. And this work is really, really important for people to understand as educators, because kids who are in second, first, and kinder, and even TK understand the idea of sharing a cookie fairly, or sharing the idea of 1/2, because they are so focused on everything being fair. And they can understand that we can partition cookies into 4 parts or 3 parts, and they can start to understand the relationship of the part to the whole before they're looking at what an actual numeric fraction looks like. And in fact, when we introduce the fraction symbol without understanding of what the relationship from the unit fraction to the whole is, that can be really confusing for young people. So the fair sharing tasks leverage understanding. So in third grade, for number and fractions, the students have to understand a fraction as 1 over b, as the quantity formed by a part when the whole is partitioned into b equal parts. Understand that a fraction ab has as the quantity formed by parts of size 1 over b. So this is really confusing when it just has the variable in there. But if you think about and understand that a fraction 1/4 is a quantity formed by 1 part, or 1/4, when the whole is partitioned into 4 parts, and understand any fraction as, for example, 3/4 as the quantity formed by 3 parts of 1/4, right? So 3/4 is 3/1/4. So this is really, really confusing when we read it like this, but if we place it in the context of fair sharing tasks, it's something that we can really develop a deep understanding about. So we're going to solve a problem in just a moment, but I'm going to ask you to go to another video for that.